The government of Saudi Arabia allocated a huge fund to boom scientific research in the country. Being the largest university in the kingdom and in the region, King Saud University took the initiative to lead in this research boom, and one of the major manifestations was the establishment of King Abdullah Institute for Nanotechnology in 2007. King Abdullah Institute for Nanotechnology is a specialized research facility. It's dedicated for fabrication and characterization of nanomaterial. Here at Kane, we have a research philosophy for excellence that is summarized into 3 main points. Originality, which is basically the true contribution to scientific community. Secondly, developing an expertise that is relevant to our area and the region. And finally, collaboration on national-wide and international-wide.
60% of the total consumption of the water that produced in Saudi Arabia is produced by desalination plants. This technology is very expensive and it's energy intensive. We work in a new membrane technology such as vacuum membrane distillation, forward osmosis. Could significantly reduce the operational cost and increase the lifetime of the membrane. By having a novel membrane based on, for example, a multi-layer hollow fiber membrane, it will have an excellent property with superior performance. Education and training is very important, and one of our main focuses here is to build the human resources that are capable to join the industry.
I do my master thesis in polymer engineering and chemical engineering department, and most of my work I've done it in this lab. I work on preparation and characterization of polysulfone, polyorthotoluidine nanocomposite membrane. We got brilliant results, which is very high flux anti-fouling membranes.
Building expert human capital through good education and training is a major objective of the Institute. This is done in context of distinguished innovative research that is, of course, the fuel of knowledge-based economy. Kane invested on a state-of-the-art facility for fabrication and characterization of nanomaterial, especially in the area of electronic microscopy, which is used basically for morphological characterization of nanomaterial, and we use it for a wide range of nanomaterial that is prepared in the Institute.
I'm working with zinc oxide and other materials that has the same electronic configuration of zinc but new material, such as barium, strontium and calcium. By doing so, we can construct lots of nanostructure with this material and achieve a lot of different property by engineering the width or the difference of the band gap. One of the main applications we're looking for is to go for the visible light and use them for light-emitting diodes, and also we can use them as window layers for solar cells. We have collaboration with several people within King Saud University and also internationally, such as in Greece and also in Turkey, to identify the sensitivity of this material for light and for some chemicals. And also we have collaborated in the United States to analyze this material using nuclear technique.
Our material, organometallic lead halides, perovskite materials are considered as a new class of semiconductor materials. The strong absorption of solar light is the first advantage of these materials. In fact, perovskite layer of 300, for example, nanometer of thickness is enough to absorb a whole solar spectrum. The first achievement for us is that we could understand the mechanism of perovskite-based solar cell. We have already achieved some good result indicating that we will be able to use perovskite as emitting diode.
The aim of our research here is actually to study nanomaterials, specifically metal nanoparticles, and look at their cellular response, toxicity, with full characterization. When we study the nanomaterials, the metal nanoparticles, we look at whether they're biocompatible, because we need them to be fully safe and we need them to have the dual properties of drug delivery applications as well as the diagnostic imaging applications. So we can have actually biocompatible nanomaterials that could be functionalized for drug delivery as well as for diagnostic imaging. With the excellent facilities at the King Abdullah Institute for Nanotechnology and very good researchers, we could actually achieve excellence results through original research as well as multidisciplinary research.
Being part of King Saud University, Kane is privileged to be surrounded by academics that are specialized in different areas relevant to nanotechnology. We utilize this proximity in developing joint projects, joint affiliations, and in this way we guarantee virtual expansion of the Institute in terms of labs, research directions, and raising the bar in scientific contribution.